Hello everyone, in this video we are going to see cyber attack in IEEE N system in PSCAD. Coming to the basic introduction, this is an architecture of IEC 61850 substation automation. Here we can see that there are three stages. One is station level, another one is bay level and process level. At station level, different coordination with the different levels and management of the substation and operation interface can be happen at the station level. In bay level, different IEDs and different bays are going to be communicate with MUs and with the station level through boost messages and MMS communication network. The bay level consists of switch gates, isolators, circuit breakers, etc. At a process level, different merging units are connected to the process bus. The merging unit convert MU is nothing but merging unit. It converts analog data into the digital data. Due to the detailization of the substation automation, here the merging unit is going to convert analog data into digital data, so that the entire digital data and substation is operating in the digital form, digital signals. So there is a chance of cyber attack due to the detailization of the substation. If any unauthorized person has the access to the process bus level, then he can alter the readings of the voltage and current parameters. Let's take an example. Here, input to the merging unit is coming from the CTPT and the merging unit is converting analog data into digital data. It's considered as a U of K, as in a sample packets. If the cyber attacker has access to the process bus level, then he can alter the readings from the merging unit, feeding to the IED. Here we can see that the U of K input from the merging unit is going altered by the cyber attacker. It became U of K plus Y of K. This Y of K is nothing but the injected data from the cyber attack. Due to this cyber attack, if the voltage and current parameters altered in such a way that if the IECs take it as a fault condition in the network, then there is a chance of giving trip signal to the circuit breaker and opening the circuit connection during if even there is a no fault. There are different types of cyber attacks. One is CTPT tap changing. The cyber attacker have access, if he has an access to the processor, he is going to change the voltage and current tap settings just simply by altering the values. Another one is false data injection. The false data injection is nothing but here we can see in example. The cyber attacker is injecting U of K, that is nothing but faulted data, to the actual parameters. This is called as false data injection. And third one is replay attack. In replay attack, the cyber attacker will record all the readings during the fault condition, actual fault condition of the system. So he is going to use same voltage and parameters to attack in the substation. These are the three kinds of cyber attacks we are going to see in this video. And for the protection of the IEEE N system, we are taking impedance relay protection scheme. The relay will give trip signal only if the V upon I, voltage seen by the relay and current, is less than the preset value of the impedance. Then the impedance relay will give the trip signal. Let's go to the simulation. This is our IEEE N system. Here we can see that we are only protecting the line from bus side to bus line. These are the parameters we are going to: voltage V8, current I8. From the data label, the voltage and currents are divided into individual phases: R phase, Y phase, B phase. Current is divided into R phase, Y phase, B. From the CTPT, RY, I8, R, I89R, I89Y, I89B given to individual CTs. Similarly, voltages are given to individual CTs. From there, the output from the CTPTs are given to the relays, impedance relay protection. Here we can see we are using A50, V8R1, V8Y1, V8B1 are nothing but outputs from the PT, and I89R11, I89Y1, I89B1 is output from the CT. These outputs are going to feed to impedance here. This protection for 80% protection of the line. A phase, B phase, C phase, A phase, B phase, C phase. This column is for 80% of the line, percent of the, and this is 200% of the protection. And this is for LL fault, 80%, 120%, and this column is for 200%. AB line, BC line, and CL. This is our Mohs circle. Here we can see that Mohs circle. The trip signal from we can see. So let's see the voltage and current feeding to the Mohs circle. No fault is applied here during a normal operation. During the normal operation, there is no line is coming inside the Mohs circle, and there is no trip signal. If any fault occurred in the system, here we can see that the trip signal is provided by the impedance. Trip signal provided by. We see the voltage and current. This is the voltage signature and current. Now during the CTPT attack, there is no fault in the system. Let's know the fault here. As we discussed earlier, the attackers will alter the CTPT tab settings. Say for EFS is increasing, he is going to alter the parameter. Even there is a no fault in the substation. Here we can see there is a no fault in the substation. The Mohs circle is seeing is a fault and it's giving the trip signal. This is one kind of attack, cyber attack, nothing but CTPT tab change. Now let's parameters to original. Now next one is false data injection. For the false data injection, we already need a data recorder. Copy this. I already simulated, took the voltage and current parameters for the false data attack. I will show you here. Here we have to enter the file name. To path take for 2. On sampling frequency. Let's see the sampling frequency 0. The first column should be the time sample. This is my IEEE NBus cyber attack, and the related file here. The related file I mentioned already. I had a file, false voltage and false current. These are the current and these are my voltages. I am just taking for A phase. This is time and A phase voltage. Similarly, current also. These are the time. A phase, B phase, C phase currents, and in this activity we are only going to take A phase voltage and current parameters. So the file should be in the same location where our PSCAD file is there. This is my PSCAD file, and here my fast data and files should be in the same folder. So let's see. Here we can see that the proper sampling of the file is needed. The sampling frequency is 6400. If I keep sampling frequency as 400, kept sampling frequency for 400 for the voltage, you can see complete my signal is not coming. Here also we can see that one extra line is coming into the graph. This is inbuilt graph, inbuilt signal. We should not take this signal. So for my simulation, my sampling frequency is 4 kHz. Keeping my sampling frequency 4 kHz. And also I have to take only second sample, not my actual signals are coming here. So to false data injection, we assume that the attackers have access to the substation automation. We can alter the parameters. So we can consider here. Let's go to master. Very taking it as fee. Here put is VR1, V8R1. So I'm taking put from here is V8R1 now. Essentially, what we are doing, as we discussed earlier, the attackers have access to substation automation. So, what we are going to do here is, from the voltage and current here via V8R and I89R, we are adding our data, our signals from the, we mentioned as FE, false data, and those data are we are feeding into the CT and PTs. Let's see what's going to be happening. Here we can see that take only a phase. The actual system voltage and currents are like this. There is no fault, nothing. But by injection of this false data into the system, the relay is seeing the voltage and current parameters like this. So the relay is giving the trip signal due to the false data injection. Here we can see that line is coming inside the mouse circle and relay is giving a trip signal. Similarly, for replay attack, the attackers recorded the voltage and current readings during the replay attack in the net. For that thing, I will show you how to do replay attack. This is also IEEE 9 system. Here I am doing AG fault with voltage fault resistance for the time instant of 1 to 1.5 seconds. I am exporting the data here. Dot legacy dot out file. This is the IEEE 9 system. Dot cyber attack. This is the bit. So my IEEE out file is saved here in this IEEE dot. Three phase voltages and current. This is already shown in previous video how to import those data. If I run the simulation here, this is my actual data during the fault from 1 to 1.5 seconds. Fault current and fault voltage. So I am going to import same data into my workspace here. I am taking a vector current and voltage vector. Here I am taking three phase voltages and current variable. Here my location at replay number system, we can see voltage and current are already loaded. Well, and this is my current data file. I am going to use same replay attack voltage and current here. Let's take during the replay attack, the attackers won't take the actual system parameters. Simply they will replace the actual parameters with the faulted voltages and current. Just disable this fully, add 0. Here during the replay attack, we are only taking faulted voltage and faulted current and we are feeding into the system. This is the actual system parameters, voltage and current. It's in normal operation, during the normal operation. But due to replay attack, the relay is seeing it waveforms in this fashion. So relay is not differentiating what is actual attack and what is the cyber attack. We can see that the replay attack, whatever the false signature we saw last time, same false signature here we can see, and the relay is going to give trip signal. Like this, cyber attack will happen in the network. Thank you.